Today we're going to talk about section 5.3, inverse functions. And so our goal today is to be able to find the derivative of an inverse function. And we're going to be able to do this without necessarily knowing what the equation of the inverse function is. So, from way back in pre-calculus, you may or may not remember that if two functions are inverses of one another, then the composite function f of g of x has to equal x. If that's not true, then the two functions are inverses of each other. So what we're going to do is we're going to take the derivative of both sides of this previous equation. So I'm going to take the derivative of the left side, f of g of x, and the derivative of the right side, which is just x. Well, on the left side, when we take the derivative, that's just the chain rule. And so we're going to get f prime of g of x times g prime of x. On the right side, the derivative of x with respect to x is just 1. Now I'm going to solve for this g prime of x term. I get g prime of x equals 1 over f prime of g of x. Now g of x is just f's inverse. So typically we're going to, instead of writing this as g of x or g prime of x, we're going to write the inverse of f's derivative, or the inverse of x's derivative, excuse me, the inverse of f's derivative, equals 1 over f prime of the inverse of x. This is the formula you will need to know. Alright, let's see some examples to see how this works. So in this particular example, we're given a function, f of x, and we're asked to find its inverse's derivative at 3. Now, we're not going to actually find the inverse function. So using the formula from the previous slide, the inverse's derivative at 3 would equal 1 over f prime of the inverse value at 3. So, order of operations, the first thing we want to figure out is f's inverse at 3. Well, we don't know what f's inverse is. This can be the tricky part of the problem. However, if you remember about a function and its inverse function, if the point x comma y is on the original function, then on the inverse function we have the point y comma x. So if we want to know what the inverse's function is when its x-coordinate is 3, that's really just the y-coordinate of f. So in other words, I'm going to take f of x, which is 1/4 x cubed plus x minus 1, and set it equal to 3. And we need to solve this. Well, if we move the 3 over, we get 1/4 x cubed plus x minus 4 equals 0. Unfortunately, that is not easily factorable. But if you turn to your graphing calculators and just graph this function and find when it equals 0, you should obtain that it has a 0 at x equals 2. So, let's summarize what this means. What this means is, on the graph of f of x, we have the point 2, 3. In other words, we plug in 2 to f of x up here, f of 2, we get 3. What that means is on the graph of its inverse function, whatever its inverse function is, we must have the point 3, 2. More importantly, its inverse value at 3 would have to equal 2. So this fraction over here becomes 1 over f prime of 2. Well, we need to now know what f prime is. We can figure that out because we have f. So f of x we're given, so f prime of x equals 3/4 x squared plus 1. And we want f prime of 2. Well, that's just going to be 3/4 times 2 squared plus 1, which is really 3/4 times 4 plus 1. 3/4 of 4 is 3, plus 1 is 4. Plugging that way back over here, we have 1/4 as our final answer. All right, let's see another example. Now this is from a past AP exam question, so the next couple examples will be similar to AP questions. This time we're told the function h is given by this equation here, x to the 5th plus 3x minus 2. We're also given a point on h. We're told that h of 1 equals 2. If h to the negative 1 is the inverse of h, what is the value of its inverse derivative at 2? All right, so once again we're going to use the equation, the formula. So the inverse of h's derivative at 2 should be 1 over h prime of the inverse value at 2. Well, once again, we need to know what the inverse function's value is at 2 without knowing what the inverse function is. So let's go up here. If h of 1 equals 2, that means the point 1, 2 is on the graph of h, which means its inverse would have to have the point 2, 1. So in other words, the inverse of h of 2 equals 1. We can plug that in right here. So this becomes 1 over h prime of 1. Well, since we know h of x, we can figure out h prime of x. Just by differentiating, we get that h prime of x equals 5x to the 4th plus 3. Specifically, we want to know h prime of 1, which is just going to be, just going to be 5 plus 3, which is 8. So ultimately, we get 1 over 8, 1/8. So B is our answer. All right, last question. The table below gives selected values for a differentiable and decreasing function f and its derivative. If f to the negative 1 is the inverse function of f, what is the value of its inverse's derivative at 4? Once again, let's use the formula. So the inverse of f's derivative at 4 would equal 1 over f prime of the inverse function's value at 4. So, once again, if we want to start by knowing its inverse's value at 4, that's basically the same thing as saying, when does f of x equal 4? Well, looking at the table, f of x equals 4 right here. Specifically, when x equals 1. So in other words, f's inverse of 4 would have to equal 1. So we're going to plug that 1 right here into the equation. So we end up with 1 over f prime of 1. Now go back to the table. F prime of 1, well at 1, f prime is negative 3. So this becomes 1 over negative 3, or negative 1/3. And that is the end.